Good morning, all. This lecture is a really straightforward idea, but it's a really important one as we get back into our proof work when it comes to congruent triangles. So this is one that, like the title says, it's really going to bring all these things together, and it's going to allow us to take all these triangle congruence ideas, side angle side, and all those things, which okay, by themselves are good and they allow you to determine, if two triangles are congruent. This idea right here, the CPCTC, is what we need to be able to go a little deeper with the problems, be able to answer more questions about congruent triangles. So it's a pretty straightforward question there. Is side MN congruent to side QR? We've got two triangles there, and what we have, we don't have any marks on those two sides. We have marks on the other two, and we've got an angle. So we're trying to determine if, and I'll put it in kind of format here, is this a true statement? Can we prove that? And that's kind of where we're headed. We're heading back to proofs with this stuff. And we don't have marks on them, but we do have enough marks to determine something else. We do have enough marks to say that triangle MPN is congruent to triangle QSR. And we know that because of side, angle, side. We have enough information given to us to determine that the two triangles are congruent. What we're trying to prove, however, is that side MN is congruent to side QR. Well, now that we've established that those two triangles themselves are congruent, we can now say that, well, MN is the first and last letters, and QR are the first and last letters. So we should be able to now say that MN and QR are congruent because they're corresponding parts. In the names, they're in the same position, and we're probably thinking that the whole time. Of course they're the same. Of course they're congruent because the triangles sure look congruent, and we've got this thing that says they are, side, angle, side. So how do we then back this statement up? How do we take this statement, now that we've proved this, which is only a statement about triangles, side, angle, side, side, all those things that we have, hypotenuse, leg, all of those are statements that prove triangles are congruent. We're not trying to prove triangles congruent. We're trying to prove that parts of the triangles are congruent. So if we have first established this, that the triangles are congruent, we can then say that side MN is congruent to QR for this reason. Corresponding parts of congruent triangles are congruent, or more succinctly, CPCTC. Once you have established that you have congruent triangles, and that's the important thing, you have to establish that you have congruent triangles, and then you go beyond that and try to prove that you've got that certain parts are congruent, and those parts could be angles, those parts could be side lengths or whatever. Once you have determined that the triangles are congruent, then you can use corresponding parts of congruent triangles are congruent. Then you can use CPCTC. Okay? In the same way that you can only use these statements, the side, angle, side, the side, side, to prove two triangles congruent, you can only use this statement once you determine that you've got congruent triangles. If you have not proven that you have congruent triangles, you cannot use this because those middle two letters, the CT, has to be true, that you've established triangle congruence. So CPCTC is definitely a longer acronym than we've used, or not so much an acronym, but initials, if you will. And but it's really important when we're talking about proving parts of triangles congruent once we have determined that they are congruent, that the triangles are congruent. Right? You're going to get some more practice on this, and we're going to be doing some proofs on this. So, but this is definitely a must to have in order to explain away what we're trying to prove. So give the practice problems a go, and let me know if you have any questions. I hope this helped.